You made it through the weekend. It's Monday and you're here in class for the Bellringer. You know, we're talking about DNA and its structure and how its structure is important. So let's talk a little more. All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class. But now you know this shape, the spiral staircase, the twisted rope ladder of the DNA molecule we call the yes, we call it the double helix, and that was first described by Watson and Crick back in 1953. They won the Nobel Prize for that in 1962. Of course, part of why they won the Nobel Prize was because they had an excellent picture taken by, I feel like I'm in somebody's living room. Doesn't that feel like? Anyway, excellent picture taken by Rosalind Franklin. Do you remember why she didn't win the Nobel Prize? Good, yeah. She unfortunately died. She died of ovarian cancer caused by exposure to X-rays. And it's ironic and it's tragic, a tragic irony that if she knew what she learned about DNA and what we learned about DNA from the pictures she took with X-rays and how DNA is affected by X-rays, she never would have taken the pictures the way she did, right? So if she knew then what she knew later, she wouldn't have done what we did then, but then we wouldn't have known what she knew later. Is that making any sense at all? Is it? Right, so we got the sides of the ladder. Those are the sugars and phosphate groups. Those are the sides. The rungs of the ladder are what we call them, the bases, right? You take one sugar, one phosphate, one base, you have what's called a nucleotide. Those are the monomers of nucleic acids. And there are only 4 possible nucleotides, 4 different bases you can have: adenine, thymine, cytosine, and guanine. And you know by now that A always goes with T and G always goes with good. Because of this relatively simple arrangement, DNA is really good at copying itself. The first thing you need to do to copy DNA is you just need to break the weak bonds between the bases, right? These are hydrogen bonds, which are some of the weakest bonds, easy to break. In fact, they use an enzyme called helicase, which breaks those bonds, right? It does hydrolysis of those bonds. And once you've broken the bonds, all you have to do is stick A's onto T's, G's onto C's, and you have enzymes that do that in your nucleus called polymerase. Remember enzymes, and an ACE? What do the enzymes do usually again? That's right, they speed up chemical reactions. Here, let's look at an animation. What DNA replication looks like, kind of animated at a molecular level. You've got the double helix here, and then it's being split in half by what's called helicase. Right? Helicase is the front, and when it splits in half, there are 2 enzymes, the little green guys here. Those are polymerases, which all polymerases do is increase the speed of A's pairing with T's, G's pairing with C's, that kind of thing. All right, and then you wind up with 2 identical fragments of DNA. All right. Now this is takes place when cells divide. They've got to copy their DNA, split the helix, make 2 identical fragments, and it's pretty quick, but it takes a little bit of time. So when cells divide, the copying of the DNA part usually is a fairly lengthy process compared to the rest of the division process of the cell. We'll talk more about that as we go.